Okay. Ini Pak, ngomong apa?
Okay, Laura, nice to see you again.
Yes.
Maybe you still remember me. I'm Farhan.
Yes.
As a Mauna, we talked with our dean and Katie for the climate change. Now we meet again with our project adjunct professor for our discussions. As we request you to include our in our team to give a college to our students. Maybe after this, Pak Amri will show the the lesson step for this, and then we need to advise you which one we can which one you can put on the STEM literation or STEM approach for this, and what kind maybe type of action for this, maybe this for the previous or greeting this meeting. Maybe Pak Amri can share this lesson for this. Thank you, Pak Amri.
Okay, thank you. I will share the screen. Okay, Laura, maybe you can see the screen, our lesson plan. This I will
Yes.
propose the lesson plan for the activity. We need your advice about this. What do you think? This in our plan, we do the activity for STEM and project-based learning approach. We want to integration of topics across multiple course. The topic is school gear. Maybe you know school gear, Laura?
Yeah.
Yeah, this is school gear. This topic there is in at least three course: machine element, basic CAD/CAM, and practical fitting. Now, now this is not integrated, so the skill and the understanding of the student is not holistic. So our objective to improve integration of topic across the different course for a more holistic and contextual understanding and skill on mechanical design manufacture. And the second objective is to enhance STEM skill. I hope you can understand what I mean.
I do.
Yes. Yeah. So we need your advice. What kind of STEM skill we can enhance with this activity, Laura? What do you think?
Have you thought of an authentic
Yes.
problem or situation where a spur gear would be needed? Example, spur gears need to be mass manufactured to make them cheaper, or they need to be of a different product, or there's a new machine that needs the spur gear. Is there an authentic situation that could be introduced to the students where they have opportunities to ask the question and then pose the problems. So under action, you have pose a problem related to designing a spur gear. Can you think of an authentic situation that could be introduced to the students that allows them to ask questions?
Oh, okay. So, we must give the situation where the spur gear used, like that, Laura.
Yeah, it'd be
The
nice.
authentic situation,
Yeah, if it was an authentic, based in something they would encounter in a job or in real life.
Okay.
The questions they are led to ask themselves about the situation and why the gear would need to be designed. So if you could think of any situation like, they've been approached by a manufacturer who needs spur gears. They need to lower the price on the manufacturer per piece, and then designing parameters for them. Something that's authentic of why they would be designing a spur gear in the first place.
Oh, okay. But the problem is now the student don't know about the spur gear. We now in the step to introduce the basic of the spur gear. So maybe we are not in optimization of the spur gear, but we now just design a spur gear to
Okay.
transmit the power.
Okay.
Only like that, not to optimize the function of spur gear.
Okay, so maybe introduce a situation
Yes.
in a machine where you have to be able to transfer
Okay.
power in a machine, and they have to come up with. So in under ask questions, they should be able to analyze the system and the
Yes.
needs of the system, and using thinking skills, which you want to develop in your students.
Yes.
They should be able to look at not only cause and effect. So for
Yes.
instance, what is the cause of the spur gear? What is the effect of the school of that gear? But they should be able to look at the mechanism itself. That
Okay.
is power. So we would call that a thinking skill,
Yeah.
and that systems analyzing.
System
So
analyzing.
instead of just providing them with all the information, a STEM thinking approach is allowing them to analyze systems. And then, so they should be able, whatever it is you're providing for them, they need to be able to come up and ask the questions or analyze that system, making observations about the system and the needs of the system. So we talk about systems analyzing, but another way we build thinking skills is we talk about energy transfer.
Okay.
And that's that's incorporating that scientific mindset in STEM. Is you could say, how is energy transferred in this system? Besides just looking at cause and effect in the system and the mechanisms that connect those cause and effects. So sometimes we think integrating STEM as specific concepts, like they have to be able to list out specific math or technology or science concepts, but it's also a way of thinking and promoting what they call 21st century thinking.
Yeah.
Foresee.
Yeah.
Okay.
They refer to those thinking skills sometimes that way, but traditionally what you're doing is you're teaching them to do systems analyzing.
Okay.
Okay, Laura. As we seen on the screen that we have some action. This for the first step as a question. We put the assign different gear ratio problem to a group. It mean to in we hope to increase the mechanism of this thinking of the students, but we should add the some you said that what it means analyze what kind of statement what kind statement we put on this action to make their analyze.
You have already posed a problem,
Pause problem.
which is good, but I would add one more and I would say analyze the
Okay,
system.
good. Thank you.
Analyze
Thank you.
the system, yeah.
Yeah, analyze the
Yeah.
system. Okay, good.
And I would say analyze the system from before you assign the gear ratios, the student should be already analyzing that system and coming up with an idea in their mind that what if the gear ratios were different?
Okay.
Remember, you're allowing them to ask questions.
Yeah.
So the students should come up with questions on their own, and that should be one that they're led to come up with.
Okay, thank you.
So
Thank you.
you want the students, yeah.
Mm.
So when you put analyze the system, you could put mechanism in there. So they're going to look for the cause and effect or the mechanism for change in the system, what's actually distributing the power, and then the effects of we call it size ratio or distributions.
yeah.
That's one way we analyze systems.
Yes.
So you should say to the student something like, okay, when you're analyzing the systems, how would different sizes, how would that affect the system? So they should already be trying to come up with that. So the different lenses for system analyzation is cause and effect, which is mechanism. And then also size and distribution. That's another way. And then another one that they can use to analyze the system is the energy in the system and energy transfer. So students are really bad often at coming up with questions.
Yeah.
If you show them a system and say, what questions do you have? They often stare at you blankly and they're not really sure where to go. But if you provide them with the correct analyzing tools, for instance, if you said, analyze this system from a size perspective. So when you're looking at the system, just think of size and distribution. Now ask a question about that.
Okay.
So if you create a worksheet or something the students are working through in large groups, the first, you could provide them some of these different ways you want them to analyze the system before you even introduced it. It just makes them focus, develop thinking skills, and now they're the ones asking questions on systems. And they will have to start thinking about how gears distribute energy or power in a system and how those different sizes and ratios. And then you can say, all right, we're going to focus on one specific question you asked, the question about gear ratio.
Yeah.
Now we're going to go there. And then you introduce gear ratios to them.
Okay. Thank you. Thank you very much. I got it. We got it for this. So the first action, we can tell we are get a question to they can analyze, and then they can they know and got for mechanism of the gear ratio to empower to transmit power of engines. Okay. And for the second step for the research, as the your your we follow your step for this is
Presentation.
presentation. If
Mhm.
we can, so the student we asked to research or explore, right?
Yes.
This the main. So is it relevant of the action of
The step.
the step?
That looks That looks great. If they are looking at spur gear designs, maybe you have some information that can direct it for them. Maybe you already have some readings, or you have a chapter in a textbook that's already available, unless you want to spend a lot of time on the research section. Some students get lost in all the information. So I would just say direct that
Okay.
as much as possible, but that's perfect. So now that they've asked all these questions and you've prompted them to analyze the system from different perspectives, now they can address different issues like the size ratio issue. And now you want them specifically researching, do you want them researching size and ratios of gears? So I would just say direct that specifically to what is going to be most helpful for them.
Okay.
So it's better to give a specific resource to them. Yeah?
If that's what you want them using.
Okay.
If you want them if you want them going on to the internet, maybe you have some already provided resources,
Okay.
Yeah.
websites that would be most helpful.
Okay. So it means we have some clue of this our student for the
Yeah.
resources. Yeah. Okay.
Yeah. And you might just possibly direct those. If you were if you as an authentic engineer were going to do this, what sources would you go to? And then help them learn how to find authentic sources that would be most helpful.
Okay. Is it any addition statement or thing for the research step, Laura?
Well, I think that's great, as long as you know where you want them to go ahead of time.
Okay, thank you very much. And we'll go to the step, the imagine brainstorming. Now, this is the point we need to know more than from you.
Okay.
Okay. So maybe you can explain to us how to make a break. They are brainstorm and how to arrange this, make helpful and effective to them.
Yeah. Do you have when I looked at that, I thought that it looked really good. Do you have a let's see. I don't really have a lot to add on that one. I think you've been very specific in outlining them what they need to define and decide and discuss. So I think that's all. Maybe, and you have formulate on there. So this provides opportunities to say, this is the math I'm going to need in order to solve this. What technology is available to help me solve this problem? Hence their CAD class. And maybe just providing them opportunities to say, this is the technology, these are the specific formulas, or this is the math that's involved. And then if there's any scientific principles such as torque, speed, rotation, that this is an opportunity for the students in Imagine to realize the different disciplines that are integrated in solving problems.
Okay.
What the point is in imagine or brainstorming is identify the steps or the technology, and then next to the plan steps.
Yes.
Correct. Then? Yes, and so in imagine is only identify. identify the step or the technology or the science or the formula to use in the next step.
Yes. So if you say, what science concepts are needed to solve this
Yeah.
problem?
Yeah.
What technology will assist you in solving this problem? Which mathematics skills will or formulas will assist in solving this problem? And then you can help them imagine everything that's needed to problem solve in engineering.
Okay.
So this mean is my opinion that of the before step we can put the important thing step that to explore the technology and science resource to help them to get the idea among
Mhm.
students. So this is the very important from the resource we give the clue the perfect clue for this they can imagine that this is the point. Okay.
Yeah, that's excellent. And then for plan, it looks great there. I mean, you've clearly identified everything they need to plan very specifically, and then what they need to create the prototype. And that looks fantastic.
Okay, thank you.
So the plan is more specific than the imagine, yeah? The
Yeah.
third
Yeah.
step.
Yeah.
Imagine is just they've just done all this research, but now they've got to imagine what is actually needed to solve the problem. And I think you've done that well. The items that are needed, a STEM approach maybe would just help them identify which science concepts are needed, which technology is available, like CAD or whatever programs they need. So that looks really great. And I think,
And for the create, fifth step, for the
yeah,
create, we just create the
Solid
CAD, the drawing, and then we use 3D printing to make a prototype.
yeah, that's fantastic. That's great.
Yeah. Okay. Nah, and then for the test, I think we can use this gear in actual situation, but only measure the product or the prototype. This is enough, or we must use on the actual.
I don't think it needs to be used authentically, but it is helpful to initiate an authentic problem. But I don't think you have to test it or use it in an authentic situation.
Okay.
Impossible to
Yeah,
use in
exactly.
authentic situation. Yes. I think we use the dimension, the correct dimension. It's already enough for the test, maybe.
Yeah.
Because of course there is dimension and tolerancing. It's enough tolerancing that can pass the test, I think.
Yeah, that the rest of it looks really, really great.
Okay.
And improve, yes.
So
Improve is next to the test, yeah.
Mhm.
Revise the design as need, and then design the scaffold. This is, I think, the next step to in the next semester, maybe to improve their design.
Yeah, that's great. All that is perfect.
Okay, thank you, Laura. And our big question, Laura, I hope you can give us good and how the assessment. This is
That's a good question.
our big problem for that.
Yeah, so one way that you can do that is you can ask the students a question where they make a claim. The claim can be arguing for their design, but they have to provide, and you decide how much. They have to argue for why their design would fix the problem.
Mhm.
So for
Argue,
instance, yeah, they would present an argument.
Yeah.
yeah.
Now that argument has to be based on evidence. So the
Oh.
evidence might be that why they had to include holes and keys might be
Mm.
why their final design is good.
Okay.
It might be why they used the number of teeth they did.
Yeah.
They would
Number
have
of teeth.
to say, this is why I use the dimensions, this is the number of teeth, this is why the design included these different aspects. So they're developing their argumentation skills, arguing for design based on evidence. So that assessment can simply be what we call claim, evidence, reasoning format.
Claim
Students,
evidence.
evidence, and then reasoning. And
Claim.
we create a rubric
Yeah.
for the students to help
Rubric.
guide that process. But it's simply, we ask a question. Is your design, will it fix the problem? You know, a
Okay.
question like that.
Yeah.
And
Okay.
then they make a claim. My design will fix the problem because, you know, a statement. Then they use evidence, and you
Yeah.
can tell them in your rubric you need 5 pieces or 5 lines of evidence to support your claim. However many you decide. And
Okay.
then in their argument, now they're writing out like they would as an authentic engineer. They are writing that out. Now, this also brings in STEM skills because some of their evidence is based in science.
So it's
And some of
better.
it's based on the technology that they used or their math that they used.
So you think it's better on writing, not on verbal?
If you want them to develop writing skills and be able to write. So for me, that's really important because I need them to be able to learn how to write, create, and defend an argument.
Great. Great.
Yeah.
Okay. Yeah.
Technical reports, yeah, like
Yes.
that.
Yeah. Yes. Okay. Good. Okay.
And then one thing, do based on this activity, it's better they do in groups or individually.
You can decide. Sometimes if you want to assess the group, you can still do the claim, evidence, reasoning, argument format. But if you want to assess the individual, it works well for that too. That just depends on you and your goals that you want. But you can use that format either way. And you can even have the students make a presentation out of it if you wanted them to. We would call that the communicating information to a group. We would consider that a skill.
Collaboration skill.
Yeah, and it's helpful for teachers as well to be able to stand in front of a class and present and communicate information. So you can also put the assessment in that format. So it just depends on your goals.
Okay. Depend on the goals, yeah. Okay.
Yeah, of where you would be assessing them. I don't know in which of those 3 classes where this would be assessed.
Miss Pak Amri, that I suggest that we give 2, in group assessment as also for the individual assessment. Means STEM skills is from this especially can can grow up by group and also is individuals. It means we can show the increment of skills, STEM skills as individually and the communication skill as a group.
Yeah.
So we must identify some activity in groups and other in for individually.
Yes,
Like that.
this is
Not
the
whole of the activity not in groups, yeah.
as technically that mean in group we can show their communication, their supporting and their collaboration. And but for the STEM skills, we can see as individually techniques as a technical report. Means the science, how they covered the science and how they are using the technology for the perfectly suitable technology they use, and then to techniques or engineering they are designed after that mathematics they are used for this is evidence of the technical report, Pak Amri.
Yeah.
Yeah.
If you want them to be very specific in their evidence, if you want them to be able to state which, any of the mathematics principles that were used, you just need to make sure you tell them ahead of time, before the assessment, what they have to include in that rubric in order to get the full points. What counts as evidence, what doesn't count as evidence for you. But you can even have the students draw something as part of that evidence.
Okay.
So you get to be in that assessment, when you write it in that format, you can be as specific as you want, which is nice. I assess a lot using claim evidence reasoning, but sometimes I just need to be more specific in what counts as evidence and what I want as evidence. And when I'm working with the students, for instance, in the brainstorming phase, I might say, need to be specific and say, this is evidence.
Yeah.
And be able to point that out. The first time that they're hearing that shouldn't be on an assessment. They should have heard that at different points in the lesson.
Sorry, Laura. Should we involve in brainstorming or just give their specific resource or like that? Or we need to involve in brainstorming or not?
Yeah, when they are brainstorming, following that brainstorming process,
Just follow, just follow. Not,
yeah,
not,
follow it
not,
up
not.
with what would count as evidence. And then when they're planning, let them know what would count as evidence. And even when they're testing their device, say, this is evidence that your gear works.
Yeah.
And so just use the language and pinpoint what would count, so that when they come to the assessment, they're not thinking, well, what's evidence? It's not the first time they've ever heard that.
Okay. So
Okay.
next step that after we know that assessment, Pak Amri, and now Laura, for this for the step we have a great lesson plan. You can choose what you can teach them what kind step is the early or the middle of the end of the lesson.
So maybe more towards the beginning, because it would be difficult to not be there maybe in person.
Yeah.
for the testing and the improving and the creating, maybe it'd be easier to be there during more of the beginning stages, introduction of the problem and the
Yes.
systems thinking, analyzing. Maybe that would be maybe that would be the best phases for me to personally be involved in.
Okay, okay, good. Thank you. So in the previous on the early, you can help us to give some information and knowledge for this our STEM integrated. Okay. Anything else? Maybe Pak Fahmi, Pak Mabi as our coordinate study program. And
For
this
the time, Laura, in our schedule, the course in Friday. On Friday, you have time at Friday, or you prefer another time?
So if the course is on Friday, would that be my Thursday?
yeah,
Yeah, yeah.
yeah, Thursday.
Okay.
That's our
So,
problem. The
yeah,
time different.
yeah. If it a Thursday evening,
Evening, yeah,
if I did
Thursday
it like a Thursday night, then it would be your Friday. Yeah,
Morning.
morning.
yeah, that would
Mm.
work for me.
Okay. If you available for this Thursday evening, that means we are available to Friday mornings early. Okay.
Mm-hmm.
Maybe you can give 1 or 2 session.
Mm-hmm.
Two,
Yeah,
So
I
you
can do two.
okay.
two, eh?
Yeah.
Okay. Maybe or if you have any video or presentation, maybe we can put them on our e-learning, our
Yes.
website, so the student can access for that.
Okay. I can do that.
Yes.
Which Thursday, when your Friday coming up, looking at the calendar, when are you thinking?
Oh, now in 9, in this 13 or 20, what you prefer?
Maybe my 19th, your 20th, then I can have time to put together a presentation.
Okay, 19 and 20. Yeah, okay.
Okay.
And if I do the evening, the 19th, what time is your class at on Fridays?
On
On
Friday,
our normal class
8
is
8
8
p.m.
8 e.m.
Indonesian
Okay.
time.
Indonesian time.
So that would be 7 p.m.
Yeah,
for me?
yeah.
Okay.
Uh-uh.
Okay.
Yeah, 7 p.m.
Okay.
Mm-mm.
On the
Okay.
19th. And
No
then
problem.
for a presentation,
Mm-hmm.
what specifically would you like me to cover or to go over? Can you scroll up the screen just a little bit? What would you like me to go over? Do you want me to create a problem, like an authentic problem,
Yeah, this is we requesting.
and then go over analyzing the system?
Okay.
Uh-uh.
Okay. If you
We
don't
agree
mind.
this.
How many students are in the class?
40.
40?
Yes.
Okay.
Big class.
That is a big class.
Yeah, the big class.
Yeah.
Okay. I can go over analyzing the system.
And
Is
Okay, okay.
are there some language barriers I should be aware of? Will the students be able to understand me, or
We are prepared
Maybe
will you
translator.
need, Omri, will you need to translate?
yeah, there is a translator.
We are
We
prepared
will
translator.
provide a translator.
Okay.
Okay, great. And then, how long do you want me to, how long is the class?
It's about 1:30.
1 hour, I think enough. If
1 and
you
1:30.
can,
As
of-
other your presentation. The minimum is 1 hour. You can be abroad to maybe 1.5 or 2 hours as your cover the presentations, because we
Okay.
are
Okay, um, I'll plan on that. And if I need any handouts for the students, I'll just email them to you,
mhm.
and then, okay, and I'll email my presentation to you ahead of time too,
Okay.
and you can
Okay.
look at it and see if you think
Yes, yes.
what you're looking for, or if it's not helpful or not, what you like, but.
Yeah. And I think we need teach them about the STEM skill
Yeah.
Yes.
they get in this activity.
Yeah.
Maybe you can give
Yes.
some description of STEM skill to them.
Okay, I can do that.
Yeah, yeah. What they can get from this activity. Yeah.
Mhm.
I think
Yes,
that will be interesting
Mhm.
for them.
okay,
Yeah.
I will do that.
Okay, okay.
Pak
Is
Fahmi,
there anything else specifically you'd like me to cover or to go over in that first session?
I think it's enough.
Okay,
and
Pak Fahmi, ada tambahan lagi?
we want to maybe prepare the assessment soonly, Pak Amri. So
Yeah.
we can discussion a bit with Laura what kind, I mean, our assessment. Okay, Pak Fahmi, your time.
Cukup,
all
Pak.
right.
Oke. Enough.
Okay.
The sinyal Pak Fahmi.
Yeah, it's
Bad
quite
sinyal.
okay.
Okay, we think
Okay.
it's enough for this
So
tonight, Laura.
Laura, thank you very
Okay.
much. Thank you
If
very
you
much.
need anything else from me, just email, or we can Zoom again before if
Okay,
needed.
yes,
Let me
thank you,
know.
thank you.
Okay,
Thank you.
Laura, I just send the, I mean, not send, I mean, it on your Instagram. Sorry if for bother you.
Oh, you're
Sorry very
We
good.
much.
follow your
Yeah,
Instagram.
just reminder.
I'm not a very good, I'm not good at social media. I'm terrible
Yeah.
about posting or looking at it, but
Okay.
I'll look for that. I'll look
Thank
for
you.
that.
Yeah. Okay.
So, all right, thank you.
Okay. See you. See
Thank
you. Bye.
you. See
See you.
you.
Bye.
See you.
Okay. See you.
Nah, apa dia jadi artinya tadi?
Pak,
Jadi dua kali,
Rudi,
Pak ya.
Rudi translate Rudi.
Lah
Jadi dua
sudah,
kali.
Pak. Duitnya udah keruan.
Ini tadi stop pula recordnya atau kaget?
Stop lah, Pak.
Stop.
Stop lah.